So good afternoon. My name is Dr. Nagaraju, Department of Computer Science and Engineering, Artificial Intelligence and Machine Learning. I am working as an assistant professor in Institute of Aeronautical Engineering, Hyderabad. Today I am here to exhibit one of the important topic related to artificial intelligence and expert systems, that is called as heuristic search techniques. So during this session we are going to handle with the different kinds of search techniques, and we are also going to see the importance of these search techniques and how these search techniques are useful in solving AI related problems. So before moving into the concepts, the different objectives means the objectives for this particular class is we are going to discuss the some of the drawbacks that exist in the traditional search techniques, and we are also going to see the importance of heuristic search techniques. Along with that, we are going to see some of the flavors, means some of the variations of heuristic search techniques. So with suitable examples, we will try to understand each and every technique one by one. So first, let us try to understand the importance of heuristic search techniques. Why? Because before moving into the application of heuristic search techniques, we need to understand what made us to introduce these heuristic search techniques. So, as I can say from here that most of the artificial intelligence problems, they are related with the search concepts. Means either you are trying to identify a path from one point to another point, or either you are trying to identify a shortest path between two points, or you are doing any sort of techniques. For example, if you are trying to solve a monkey banana problem, or if you are trying to solve a water jet problem, such kind of applications, definitely it will include some kind of search techniques. Until and unless you perform some search process, you cannot clear that problems. So up to now, means before the concept of introducing these heuristic search techniques, we have seen some of the search techniques in the earlier sessions, which we can say that they are the traditional search techniques. Why they are traditional search techniques means they include some traditional approaches through which you can solve only some basic AI related problems. But as we know that the complexity is very high in the artificial intelligence problems. Means whenever we say that it is AI related problems, we cannot think that the problem is too simple to solve. Definitely each and every problem is having their own complexity. Why? Because artificial intelligence programs, they are going to deal with the real kind of problems. So when you are trying to implement this traditional search techniques, it will be very difficult for us to get the solutions. So what we are doing is we are trying to identify a alternative so that we can have a very good technique which can exhibit or which can implement to our search process and get the solutions within the shorter period of time. So the problem with the traditional search techniques is they cannot solve the complex problems. So what we are doing is we are trying to identify some of the techniques. They are the newly coming techniques, we can say. Those techniques we are calling it as here the heuristic search techniques. Means the heuristic search techniques is also some kind of a search process itself. They are also going to implement some search process itself, but rather they are not handling the simple problems, but they are handling more complex problems. So such newly identifying techniques here, we are calling it as heuristic search techniques. And these search techniques are sometimes we can also call them as heuristic search algorithms. Why? Because we are making use of one particular function. We call it as a heuristic function. And we will try to see what this heuristic algorithm is and how this heuristic functions is useful for us in order to do this search process. Now the question comes is the heuristic algorithms, are they really intelligent? So we cannot say until and unless we implement those techniques. But with the previous experiences, we will come to know that they are not so intelligent. Why? Because with the help of these heuristic search techniques, you can able to get a solution. But we cannot guarantee that that solution is a best solution. But only the thing is here, there is an advantage with the heuristic algorithms. What is that advantage is, it is going to take the help of the previous things. Means they are going to make use of feedbacks. Means from the feedbacks, the heuristic search technique is going to learn something and it will direct us means here the AI agent towards the goal state. Means heuristic search techniques will be more efficient whenever they are making use of the feedbacks from the data, so that you can direct towards your goal state. And there are different types of heuristic search techniques. In that, the first heuristic technique, we call them as it is a uninformed. Okay, here we cannot say that here a heuristic search function we are going to use in these things, but we need to think of these techniques as the search process without a heuristic function. Means whenever you are not implementing any kind of heuristic function, then we can say that it is uninformed search algorithm, or the other name is also there, which is called as brute force algorithm. I am repeating the point. Heuristic search techniques, they are useful in performing the search activity, which can be used to solve AI related kind of problems. In that, you can implement this search process. Means you can continue this search process either by implementing a heuristic function or without using a heuristic function. And when you are not using any heuristic function, then we can call that kind of search activities as uninformed. So in this case, what happens is we are going to identify, or we are going to search for all the possible candidates. So after identifying the possible candidates, we are going to compare it with our goal. Means checking the possible states with our goal. Whenever a particular candidate is matching with the goal, then we can say that we have succeeded in the search process. So we can say that this is not a somewhat systematic process when compared with the other type of heuristic algorithm. Okay, so let us try to see the other thing also, which is called as the informed search algorithms. So in this case, what happens? These algorithms are specific to a problem. Initially, we cannot guarantee that the uninformed search algorithms, they are applicable only to some kind of problems. But here in this case, it is not like that. The informed search algorithms, they are specific to the problem. Means you cannot apply these algorithms to any kind of AI problems. So here what we are doing is we are making again the same thing. We are making use of the heuristic function, which we are going to apply to guide through the search space. Here we know that the search space is nothing but some state space in between the starting point and the ending point, we can say. So here what is happening, with the help of these heuristic functions, if you could able to reduce the time taking to perform the search activity, then such kind of search process, we can say that an informed search process. In order to exhibit these things, the algorithms, whatever you are applying, then we can say that they are the informed search algorithms. You can clearly identify the difference between uninformed and informed here itself. So if you are using some search process, or if you are implementing any algorithm to perform search process without any heuristic function, then we can say that it is uninformed. If you are doing the same thing with the help of some heuristic function, or by implementing some heuristic technique to a specific problem, then we can say that such kind of a search process is informed search, and the algorithm you are applying, we can say that it is informed search algorithm. The main advantage of informed search algorithm is it is going to reduce the time taking to perform the search activity. Why? Because the heuristic function is going to guide us to move towards the goal state. But in uninformed search, it will not be like that. Means we are randomly going to select one particular state and we will move accordingly. But we cannot guarantee that that particular path, wherever we are moving, is going to make us to reach to the goal state. Now the question comes is how the search really proceeds. So as we know that the search is going to proceed by using the current information about the problem. By using the current information about the problem, and which means it is going to select a path. In search technique especially, what happens, our primary motto is to identify a path between the initial state and the goal state. So in this case, what happens, we are going to take the advantage, or we are going to consider or take into account the information which is related to the current path and trying to predict the path. And how that path should be, moving and should make us to move towards the goal state. This is the actual process that happens in the search activity. Here, but what happens is sometimes we may not guarantee that we are going to find the best possible solution. Initially, I mentioned that by using the heuristic search techniques, you could able to identify a specific path which is pointing towards the goal state, which can makes you to move towards the goal state within the shorter period of time. But we cannot guarantee that that is the best solution what we have or what we can achieve. Okay, that's why we are saying that it does not always guarantee to find the best possible solution. So actually these techniques, what happened, they are going to take the help. Okay, they are going to take some kind of help in finding a solution with reasonable time period. Means if you want to implement heuristic search techniques, you have to think about only the time period. If you want to identify a specific path in between the current state, initial state and goal state, then better to go for the heuristic search technique only. If time is the major concern to you. Otherwise, simply you can go for the other techniques. Why? Because the heuristic search technique is not giving the best solution. It means we cannot say that it is an optimized solution for our problem. Now, these many number of times I am using the word called as heuristic. So actually what this heuristics will do for us? Actually, heuristic is a method which is going to improve the efficiency of the search process. Which is going to improve the efficiency of the search process. For example, you see, think that this is your initial state. From this initial state, you want to move towards the goal state. Okay, this is your initial state and this is your goal state. As I mentioned that during our search process, our primary duty is we need to find out the path. Okay, means we can say that it is a path, or we can say that it is a shortest path. Okay, why? Because path, we can say that it is a good result. We can say it is a good result. Whenever we say it is a shortest path, then we can say that it is a best result. Okay, means every time in the search process, our primary duty is we need to identify a specific path which can point us towards from the initial state towards the goal state. So in this case, what happening? We are going to make use of some heuristic method. We are going to make some heuristic method. So what happens in this case? Heuristics may not find the best solution, just now we discussed, but we can guarantee that we may definitely find a solution. We can definitely find a solution. For example, in this case, think that there are three different paths. From the initial state, there are three different paths which can make us to move towards the goal state. But here the biggest question is which path we need to select. We need to select which path, either this one or this one or this one. So in this case, in this ambiguity, the heuristic function is going to support us to decide which path will be the best path, so that you can continue your search process and move towards your goal state. Okay, so these are particularly useful in solving tough and complex problems. Just I mentioned that heuristic search techniques we are going to use for the problems which are having more complexity. And the problems we are going to deal means the problems which are going to take infinite time. Even there are some problems where it is going to take some lifetime of a human to solve it. The best example we can say that when we are dealing with a traveling salesman problem, right? If a salesman have to visit 10 number of villages or 10 number of cities every day, so generally what he will try to identify the shortest path among the 10 cities, so that he can cover it within the shorter period of time or within the given period of time. So if you want to find out, means being a human, if we want to find out the shortest path among those 10 cities, it will be very difficult. Of course, we may solve it, but it is going to take long time. So such kind of techniques we cannot solve being a human. So what we are doing, we are taking the help of this heuristic search techniques and writing some AI program, and which can give us the solutions within the shorter period of time itself. Means no need to wait for longer period of time. Okay, that's why we say that every time heuristic search techniques are going to deal with the most complex problems, but not simple problems. Let us talk about the heuristic function. So heuristic function is nothing but it's a kind of implementing some kind of approach, we can say, where we are going to search or we are going to find to measure. Means with the heuristic function we can do two things. One is either you can go for a search process or you can go for the measure process. So what do you mean by this measure and what do you mean by this search? See how far a node in a search tree seems to be from a goal. Okay, for example, here the same thing. from initial state to the goal state, what is the distance between these two? If you want to measure the distance between these 2 points, then you can make use of heuristic function. Or otherwise, if you want to find out the shortest path, one I am telling is, one is the distance, or otherwise you can say that the path. Okay, means with the help of this heuristic function, right, you can make 2 things. One, either you can perform the search or you can perform the measure. Search is nothing but identifying the path between these 2 points. Okay, of course, this direct moving from initial state to goal state is not possible until and unless your state space is having only 2 nodes. But if there are some other things, definitely you need to identify the path, which one is the better one. That's why we say that every time with the help of heuristic function, either you can go for a search activity, means what should be our next state. For example, if this is your initial state, then what should be the next state? Means where I have to move. For example, if this should be your current state, then heuristic function is going to help us to move to this particular state by ignoring these 2. So in this case, we say that it is a search process. And another one is measure. Measure means it can be some sort of distance. Means I want to identify the distance between 2 different points, or distance between 2 different nodes. So in that case also we can make use of these heuristic functions. Okay, heuristic functions are also going to make a comparison, right? A comparison of 2 nodes in the search tree. In the search tree to see if one is better than the other. Just now we mentioned that whenever there are 2 different paths from our current state or from the initial state, which one we have to select. So whenever you apply some heuristic function, it is going to give some numerical value as output. Okay, for example, think that this is a numerical values given by the heuristic function. So these numerical values you can consider, or you can treat them as some weights, or you can treat them as some distance. So what these values are telling, if you want to move, means here the AI agent. If the AI agent wants to move from this particular point to the next points, so which point should be selected? Which node should be selected? Most of the cases what happens, the node which is having the shortest distance from the initial state or the current state, then that will be selected. So here what happened, we are having only 4 as a distance between these 2 points. Then simply by ignoring this path, we can move towards this node. Okay, so in this case also we are going to make the use of these heuristic functions. And try to understand each and every time we are going to make use of these heuristic functions so that we can always move towards the goal state. We can always move towards the goal state. That is our motto. Means in simple words, we can say that this heuristic function is going to support us whenever we are having multiple paths from our initial state or current state. Why? Because we will get an ambiguity. We will have some sort of confusion which next state we have to visit. For example, if you visit or if you move towards the state or a node which does not make us lead us towards the goal state, then our search process will become waste. Okay, we are going to move. We are going to move in the state space itself without reaching to the goal state. So identifying the current node is also very, very important. Sorry, identifying the next node, proper next node or perfect next node is also very, very important. So in that case, heuristic search technique or heuristic function is going to help us. So as I mentioned earlier, there are different kinds of heuristic search techniques. In the heuristic search techniques, first of all, we will try to understand one of the search technique which is called as generate and test search. Of course, in this technique, in this search process, we can say that we are not making use of any heuristic function. We are not making any use of heuristic function. So what we are doing is, from the initial state, if we are having 3 different road paths, so what we do is blindly, we can say uninformed or blindly, we are going to select either of these 3. Either we select this one or this or this. Okay, means randomly. The selection process of the next node will be done randomly. Right. So what in this case, what happens? We cannot guarantee that Okay, we cannot guarantee that that should be the shortest path between the initial state and the goal state. Okay, but in some cases, in few applications of AI, even generate and text search technique is also useful for us. We will try to understand. I mean, before, in this case, we are not implementing any heuristic search technique, but we will try to understand how this algorithm can also be useful in performing the search activity. So we can say that among all the approaches or among all the techniques, this one is the simplest algorithm or simplest search process. It is called as generate and test. So what is it is going to be implemented in 3 different steps. The first step is generate a possible solution. Generate a possible solution. So it can be generating a particular point in the problem space or generating a path from the starting state. 2 things, right? So how it will be 2 things, you see. First of all, we need to identify or we need to start from one node. So what node it should be? So if it is our search process, if this is our search process, we need to select one particular node or one particular point in the state space or in the search space. So the first duty means in the first step of implementing this generate and test technique is we need to identify this node. We need to identify this particular node, and once the node is identified, you can call this one as the initial state or you can call it as a current state. Initial state or current state. Of course, if this is your first node, then we can say that it is the initial state. If it is not your first state, if it is in between here or something here, then we can say that it is a current state. Right? Generally, we use this term current state not for the initial state node. Current state means next to the initial state. It can be anything. Okay. So our first duty is we need to identify a starting point from where we have to perform the search activity. So once we have identified the node, the initial state, then what we have to do is we need to compare. We need to compare this one with the actual goal state. We need to compare with the actual goal state. If this initial state means the state which you have identified in the first step is exactly matching with the goal state, then we can say that we have reached to the goal state and we can stop our search process. Okay, that's why whenever you are generating a specific state, means whenever you are identifying or moving to one particular node, then you have to compare it every time whether that node is a current state, goal state or not. If it is a goal state, then stop your process and you can say that the search is successful, or otherwise you have to continue the process. We can say that this is a looping kind of thing. Means this looping means the searching process is going to continue until you reach to the goal state. So in the generate and test procedure, we are going to first generate the possible solutions. So once it is done, our next duty is we need to test it to see if this is actually a solution or not. Solution means to where you have to reach. For easy understanding, we say that every time it is a goal state. Means solution here, we can call it as a goal state. Means whatever the thing you identified in the step 1, if it is matching to your goal state, then you can say that your search is successful. If it is not the case, means if the solution if a solution has been found, so what we are doing, simply we are quitting. Right? Otherwise, what we are doing, again we are going back to the step number 1. Okay, so this is called as some simple method of implementing the search process called as generate and test search process. And we can also say how these techniques are implemented, how this generate and test technique is implemented. We can say that it is a depth first search procedure. Okay, it is a depth first search procedure, means it will select a particular path and it will keep on going in that path itself. It is not going to identify the other possibilities. Why? Because it is a random selection of the next node. So it is not going to think of the other nodes in the same level. That's why we say that it is a depth first search procedure. Okay, so it is a depth first search procedure since complete solutions must be generated before they can be tested. Okay, for efficient implementation of this technique, what we have to do is we need to identify the complete solutions. Okay, we need to identify the complete solutions, and then after we have to start for the testing. So as I mentioned earlier, right, it is going to operate by generating solutions randomly. But in this case, we cannot guarantee that we are going to reach to the goal state. Okay, it is not guaranteed. Or if you reach to the goal state, we cannot guarantee that it is a optimized one for us, optimized result for us. Okay, so the search process, if it is proceeding systematically, means if you continue this process in a systematic manner, then you can guarantee that you may get a solution at some point. Right? We are not talking about the time constraint, remember. Why? Because this is purely a non-heuristic search method, we can say. In generate and test search, we are not implementing any heuristic function. So we never talk about the time. We talk about only whether we could able to get a solution or not. So if we implement this algorithm or this technique in a systematic manner, then we can guarantee that a solution can be identified. So if it is not the case, means if you are picking a path node which is not actually making you to move towards the goal state, then we cannot guarantee that you will get the solution. So that is a point here. The search process proceeds systematically, but some paths, what happens is, some paths are not considered. Why? Because they seem unlikely to lead to the solution. Means that particular path may not make you to move towards the goal state. And also we can say that this heuristic search technique we are implementing based upon the depth first search, as I mentioned just now. Okay, with this one again you can make use of this concept which is called as backtracking. Means whenever you find or you identify that, here you means every time AI agent. Whenever an AI agent identifies that the current state where it is there now is not making it to move towards the goal state, or it is not the correct path which can make us to move towards the goal state, then you can make use of backtracking technique, or we can say backtracking approach. So what happens in this case, we are going to go back to the state where we came from. Okay, that's why we are saying that generate and test search technique is a heuristic kind of technique. It can means you can implement this heuristic search technique even in generate and test also. Before I mentioned that we are not implementing any heuristic search technique or any heuristic function in this approach. But if you want to improvise, this generate and test technique, then what you can do is you can make use of this heuristic search technique. Okay, means only adding the heuristic search technique to the existing generate and test. So what happens in that case, you will get a chance that there you can do the backtracking. So if that approach is available, means if that thing is available to us, then we can guarantee that we are going to find a solution. Okay, so in this case what we are doing, all the solutions are generated and tested for the best solution. Okay, then we can say that generate and test means first we are going to generate the current path. So, okay, we are going to generate the next path, new path, we can say new path or new node in the tree. Okay, then what we are doing, we are trying to compare that one with the goal state or comparing with our solution. If it is not the case, make use of this heuristic search technique process, apply the backtracking, go back and continue the process. So whenever you are implementing this heuristic search technique, means heuristic function concept to the generate and test, then we can guarantee that we can get the best solution. Why? Because several possible solutions are available for us. From that available solutions, you can pick up the best one. So here the primary responsibility will be to the generator. Why? Because if the generator could able to give the better results to us, then we can move in that particular path and we can reach to the goal state. So how can we guarantee that a generator is a very good generator? Means which will makes us to move towards the next state. So we will try to understand the different properties of a generator. So one generator, we can say that it is a complete generator. So why we are saying it as complete? Why? Because it is going to generate all the possible solutions. It is going to generate all possible solutions, and remember, it is also going to take into consideration all the paths, or we can say all the possible states in the state space. Means by considering all the possible states in the search process or in the search state, okay, if you could able to generate all the possible solutions, if it could able to generate all possible solutions, then we can say that it is a very good generator or a very complete generator. So in this case, we can guarantee that our algorithm is going to converge to the current solution at some point of time. Okay, so if that is called as here the complete generator. And also sometimes what happens, a generator can be non-redundant. It should be non-redundant. So what do you mean by non-redundant? It should not supposed to generate the same results for multiple number of times. If it does, what happens? The algorithm or the technique is going to spend much more time in generating them. So we cannot guarantee that. We are going to get the best solution. Of course, you may find a path or you may find a shortest path which can make you to move towards the goal state, but we cannot guarantee about the time. Why? Because the time taken by the algorithm is for generating the multiple solutions. Means same solution it is generating for multiple number of times. Then we can say that it is redundant. Whenever it is redundant, the algorithm is taking time to generate such kind of results only, solutions only. Then how can we guarantee that within the shorter period of time we are going to get the solution that can reach us towards the goal state? So here a generator we can say it as a good generator until and unless it is non-redundant. Means once a particular solution is given to us by a generator, it should not supposed to give the same result again. Means the solutions whatever the generator is providing to us, those solutions should be unique. Okay. And sometimes a generator can be informed. So in this case, what happens? We are going to generate. It should have some knowledge about the search space within which they maintain in the form of any array of knowledge. Array of knowledge is nothing but, for example, you see from this state, think that there are 3 different paths. Okay, the weights of this path, it is 4, some 7 and 5. So what happens, the good generator, if it is informed, so what happens, it is going to store these values in the form of an array. Means it is going to store like this, 7 and 5. So what it is doing, it is storing these values. Why? Because whenever the AI agent performs the backtracking, he need to come to know the weights of the previous state. Okay, for example, think that the AI agent is somewhere here. Okay, he found that this is not the correct path, making it to move towards the goal state. So what it is doing? It is doing a backtracking. So it is performing the backtracking. Okay, or otherwise if your AI agent is here and it is performing the backtracking, thinking that this is not the correct path. So what happens when you are in the initial state? When you are in the initial state, again you need to perform the search process. So if you won't store these values 4, 7 and 5, if you are not storing these values, what happens? Again you need to implement this heuristic function, and again you have to get these values, and based on these values you have to select which one is the minimum one. It should not supposed to happen. That's why whenever we say that a generator is a good generator or a generator is an informal generator, means whenever that generator is storing all the values. Okay, all the values, and it has to maintain those values as a form of an array. Okay, so this can be used to perform the search how far the AI agent is from the goal state. So with these values we will come to know. Means the AI agent is going to know, right, how much far he is from the goal state. Okay, so how much he is far from the goal state by calculating the path cost. We can say that this 4, 7 and 5 are also the path cost, and even find a way to reach the goal. 2 things may happen. What is that? One is either you can go for the distance, nothing but here the path cost, or otherwise you can go for the path, or we can say it as a way which can makes us, which is allowing us, moving us, making us to move towards the goal state. Okay, then such kind of generator, we can say that it is a informed generator. Okay, so that is all about generate and test search technique. So let us try to see the second flavor of this search technique process, that is called as hill climbing. This hill climbing approach, we can say that it is one of the variant of generate and test process. Why we are saying it as one of the variant? Because in the generate and test procedure, during the time of search process, we are selecting the next path, next node, right, by using some random method. Means there is no specific method to select the next node. But in the hill climbing, it is not the case. Why? Because this hill climbing, it is going to make use of heuristic search technique. Means it is going to implement heuristic function. This function will give us some weights or some cost of the path through which you can make use of them, so that you can select the best one and move towards the next goal state. Okay, so we can say that it is a variant of generate and test, which is going to use the feedback again from the test procedures, and it will help us to decide. It will help us to decide to which direction you need to perform the search activity. Okay, just now we discussed that we are going to select the next node based upon the weight or the path cost given by the heuristic function. So that's why we say that every time this hill climbing can be a better approach. Okay, it is a better approach, or we can say it is an improvised approach for the generate and test technique. Most of the cases, what happens, a pure generate and test procedure, it is going to give the responses either in terms of yes or no. Okay, whether I could select this node as either as a next node or not. If it is yes, simply it will say yes. If it is no, it simply says no. But if the test function is augmented with the heuristic function, so if the same process, if you implement by using this heuristic function, so what happens, it is going to provide us an estimation which will allow us to identify how close our given state is to the goal state. Okay, means we can say that the generate and test procedure is some kind of blind process. It is some kind of blind process. But in this heuristic search technique or hill climbing process, we are implementing this heuristic function. We can say that it is not a blind process. Why? Because we are going to follow a systematic approach by implementing this heuristic function, which is going to give some kind of value to us. Based upon that value, either it can be a weight, or it can be a cost, or it can be a distance. Okay, by taking that help of that values, we are moving towards the goal state. So in hill climbing also there are two different approaches. I mean, there are two different flavors, we can say. The first one is called as the simple hill climbing technique or simple hill climbing algorithm. Okay. So in the simple hill climbing algorithm, what is the first step we are doing is we are trying to evaluate the initial state. The same thing what we have done in the generate and test procedure, here also we are doing. In step number 1, we are trying to evaluate the initial state, and we are going to make a comparison. Remember, in this search process, every time, whenever you are changing your positions from one node to another node, you have to keep on going to do the comparison. You have to keep on comparing your state with the goal state. Why? Because we cannot guarantee that, we cannot ensure, or we cannot be sure that our current state can be a goal state or not until and unless you perform the comparison. So once the initial state is evaluated, and your next duty is you need to compare it with your goal state, whether it is your goal state or not. So if it is your goal state, then simply you can quit. Why? Because your search process is complete or successful. Otherwise, means if the initial state you have generated is not matched with your goal state, that means that still there are some more nodes in between the initial state and goal state which you have to visit, or which you have to move towards them. So whenever the initial state generated is not matching with the goal state, so what we do, we are not going to quit. We are going to continue this process. This is step number 1 in the hill climbing approach. In the second step, we are going to perform the looping. Just now, I said that looping is a very common point in each and every search process. Means we are going to perform the search until and unless we reach to the goal state. So this looping is also going to continue. So in second step, what we are doing in hill climbing approach, loop until a solution is found. So how to perform this loop? At each and every moment, okay, at each and every move, we can say you have to keep on applying the operators. So in this looping, what you have to do, you need to continue this looping process by applying all the operators that are available. Whenever you feel that the operators are not available to apply, then you can stop your looping process. Okay, means in second step, what we are doing, we are continuing the looping until a solution is found, or we can say until there are no new operators left to be applied to the current state. That is our second step. In the second step, again you see select an operator. So how we are going to proceed this one? How we are going to fulfill this step number 2? So first what we are doing, we are trying to select an operator. Okay. So the selection of the operator is also very, very important. That operator should not be applied in the previous states. It should not supposed to apply. So you have to select the operator which is not applied in the previous states. You select that one and you apply it. Okay, whenever you apply that operator, what happens? A new state is going to be produced. Okay. So what happens once it is get done? That means that we have evaluated the new state. Okay, so every time, see again here also you need to do the comparison. Remember this point every time, means whenever you are in a particular node, when the AI agent position is in a particular node, every time you need to perform the comparison with the goal state. So what happened in this case, during our looping activity, we have created a new state in the state space. So what happens once a new state is identified or created, our next duty is you need to again compare this one with the goal state. Why? Because we cannot guarantee that may be our goal state. We are not sure. So what you are doing, again we are doing the comparison. If it is matching, means if the newly created state is matching with your goal state, then simply you can return it and you can quit. Why? Because you have reached to the goal state. No need to continue the search process. But if it is not the case, okay, if it is not the case, but it is better than the current state, it is better than the current state, then what you have to do? You need to change your current state. You need to change your current state. So how it will be, you see, as it is a hill climbing, let us take one simple example. For example, this is a hill. Okay, this is a hill. So what happened? You are for example, this is your initial state. Okay, this is your initial state. What you have done? You applied an operator. When you applied an operator, what happens? It is going to generate a new state to us. So what we are doing? We are going to compare this new state with the goal state. So actually, what is our goal state? We need to identify the highest one, the peak point. This one means this one is our goal state. So from where we have started, from this point we have started our search process. So what happened? Once you applied the operator, you have got a new state. So what you have to do? You need to compare this one with the goal state. As we know that this is not our goal state. But when you compare with the initial state, this is a better one. Why it is better one? Why? Because it is very much near to the goal state. Means the newly generated state is better than the current state. This is your current state. Na? So what you have to do? Now you need to ignore this one and you have to consider this one as a current state. Again, what you will do here? Here also you will try to apply one operator, which is not applied before. And you will get a new state. Whether I should consider this one as a new state or not. So you have to make a comparison. When you compare these two, this one is the better one. Why? Because it is very much near to the goal state again. So you don't consider this one as a current state. You change your state, making this one as a current state. Means the newly generated state as a current state. So you have to keep on going like this. Right? Every time you are performing the comparison, So whenever your current state is here, and after applying some operator, what happens? You will move to this point. Means your current state is this one now. So now you try to compare this current state with the goal state. So what happens? Both are matching. Both are matching. That means that you have reached to the peak point. So you stop the search activity. Okay. I mean, generally in hill climbing approach, we are going to see, or we are going to identify the highest point. Highest point. In simple words, we can say that some global maxima. We can say some global maxima or global maximum. Some maximum also we can consider. Okay, at present global we will keep aside. We will try to think this global in the next coming slides. Okay, why? Because this is the maximum point. This is the maximum point. So in the hill climbing process, our duty is we need to identify this one. So how we are continuing our looping? In this way. Every time select one particular state, apply the operator which is not applied earlier, try to get the new state, and you compare the new state with the goal state. If it is not matching, you compare your present state with the current newly generated state. And if it is a better one, you change your current state position. You change your current state. You keep on going unless you reach to the goal state. Okay, so this is all about the simple hill climbing approach. Okay, so there is another flavor which is called as the steepest ascent hill climbing. It is called as steepest ascent hill climbing. So we need to understand what do you mean by this steepest and what do you mean by this ascent. Actually, steepest means it is the longest one. We can say it is the longest. Okay, what do you mean by ascent? Means it is a kind of increment. Okay, steepest means longest and ascent means increment. So in this we need to make one variation between the simple hill climbing and this process. So what happens in the search process whenever you are applying some heuristic function and you are going to get some values. Generally, when we are moving from one point to another point, we are going to pick up or we are going to select. Okay, we are going to select a particular node which is having the shorter distance, which is having the less path. Means initially we used to do like this. From the initial state, if there are 3 different paths, the weight of this path is 5 and this one is 7 and this one is 5. So what we do, generally we are going to pick up the shortest one, the path which is having the shortest distance. So what happens? Simply we are going to ignore these two and we will try to move from this state to this state. This is the actual procedure we followed in the previous search techniques. But in this case, we are not going to consider the minimum one. We are going to consider the maximum one. Okay, how it will be, you see. For example, think that this is node 1. From node 1, again we are having node 2, node 3 and node 4. Okay, from node 3, again we are having node 5 and node 6. Okay, then finally we are having node 7. So this is our initial state. And what is our goal state? This is our goal state. This is our goal state. So how we have to perform the search activity starting from goal state to the initial state to the goal state. This is very, very important. So in this case, what we are doing is every time we are going to keep trying to find out the weights. Okay, for example, the weight of this one is 4, weight of this one is 7 and this one is 5. So what happens every time we are going to store these values in the form of an array. Okay, so initially what we do is we are trying to make this one as a max as -1. Max as a -1, right? According to the algorithm, we can say the successor. So the successor is -1 here. So what we do, we are going to compare this 4. So what happens? 4 is less than 7. 4 is less than 7. So which one we have to select? We have to select the maximum one. So in this case, what happens? The maximum value will become 7. Next, keep on doing the comparison. 7 and 5. 7 is greater than 5. So which one is the maximum one? 7 is the maximum one. So there will be no change in the maximum value, successor value. Why? Because successor is already having 7. So in this case also max will be 7 only. So what this value is indicating means if your state is here, If the AI agent state is here, so what should be the next state? So the maximum, the value which is having in max, that should be your next state. So simply you have to select this one. Means we are simply going to ignore these two paths. Okay, that's why we say that it is the steepest. Steepest means the longest, we can say. The maximum value, we can say. Okay, so in the steepest ascent hill climbing approach, our first step is we need to evaluate the initial state. So this is a common step we do in every such process. Okay, so in the first step, we are evaluating the initial state, and if it is the goal state, again doing the comparison. If it is a goal state, then simply exit. Otherwise, what you have to do is you need to make that one as the current state. You have to make that one as a current state. If it is the first state in your search process, then you can say that it is a initial state. Okay, in step number 2, so what we have to do is we need to repeat these steps until a solution is found or the current state does not change. The current state does not change. For example, think that let the target be a state such that any successor of the current state will be better than it. Okay, means target will be the better node for us, so that we can move towards that point. Okay, so every time what we are doing, we are keep on applying the operator. We are keep on applying the operator and trying to create a new state and evaluate that new state. If that new state is a goal state, simply quit. Otherwise, you compare it with the target. This is a new step we included in the steepest ascent hill climbing. Okay, if what we are doing, we are applying some operator, trying to generate the new state and perform the evaluation of that state by doing the comparison with the goal state. If this is not the goal state, so what you have to do? You have to keep on comparing with the target one. If the state is the better than the target, so what happens then? Your state is the target state. If the target is better than the current state, then we can say that the current state is a target state. Then finally, you can do the exit process. Chances of failure means, is there any chance for failure of this algorithm? Okay, so there is some chances. Why? Because not only for the steepest ascent, even for basic hill climbing approach also, there is a possibility for failure. So in what cases it is? See, both basic and steepest ascent hill climbing may fail to find a solution. How it will be? Either sometimes it may get terminated. Terminated means without finding any goal state or without finding any new states, or sometimes without finding a better state, like that also. So what is the reason that makes these algorithms to get failed? Means there are three things. One is the local maximum, plateau, or the ridge. So we need to identify what do you mean by this local maximum, plateau, and ridge. This diagram will clearly explain us how the things are. So for example, this is our hill climbing problem. So in these hill climbing problems, what happens? We have considered as a global maximum, and this one we have considered as a local maximum, and this one is some flat local maximum, and we can say this one is some kind of plateau. Okay, ridge means some kind of falling here. This will be considered as a ridge. Ridge means continuously, right? You are going down. Means your newly generating state is not the perfect state to your initial state, your present state. See, you try to observe this one. If your state is here, you are applying the operator and you are moving towards this one. You are generating this one. So what happens? You are doing a comparison. What is that? Is this one is better, this position is better, or this position is better? So obviously we know that this is the better position. So what we are doing? We are trying to change our position to this one. Means our current position is this. Our means again the AI agent. So we are doing the same process. Okay, we are going to keep on changing our current states. Why? Because there is these states are better than the previous one. But what happens if your current state is here? You have applied some operator and you got a new state which is here. So what happens when you do the comparison? Okay, when you do the comparison, we cannot say that this is a better state. This is a better state. And similar to that one, again you applied the operator and you move to this point. Again, this is also not the better state. So what is happening every time, you are getting some new states which are not the better states to your current state. So in this case, what happens? The algorithm is going to fail. This is called as some ridge kind of activity. Okay, we will try to see what do you mean by this local maximum. You try to observe this local maximum also. For example, think that this is your current state. So what happens? Again, here also you will apply some operator and you will try to identify a new state. Do the comparison. So you found that this is a better state than this one. So what you do, you will change your current state from this point to this point. And next what happens? Again, you are going to move to this particular point. Then after, you are going to move to this point. So what you feel is that whenever the newly generating states are not the best states to your current position, so what you think is that you think that you have reached to the maximum. You have reached to the maximum. So how it is local maximum means, along with this hill, okay, along with this hill, there is one more hill is also there. So in this given state space, of course, this complete thing is a state space for us. So in this complete state space, you need to identify the maximum. But according to this definition diagram, we can say that this is the global maximum. But what happened, as our current position is here, we could able to reach to this place, and then after we are identifying some new states which are not perfect to our current state. So what we feel that this is the maximum one. So we feel that our search process is successful. But unfortunately, what happened in this search space, in this state space, again we are having one more hill also. So in the given this scenario, you need to identify which one is the one, which one is the maximum one. Means you should not supposed to identify the local maximum. You have to identify the global maximum. Okay, so we are trying to talk about the failures, means the situations which can make the simple algorithm, simple hill climbing algorithm and the steepest ascent algorithm to get failed. Okay, so what is the third one? You see the flat. Flat means you can say that it is a plateau. For example, think that there is some kind of hill like this. Okay, some flat is there. Again, there is one more. Your current state is this one. Your current state is here. So what happens? Again, here also you are going to apply some operator. You will get a new state. So these two definitely will have same value. So you will think that, means the AI agent will think that this is not the better one. This is not the better one. So it will try to identify some other one. Trying to identify some other one. What happened here? Continuously it is able to generate the same value points, same value states, we can say. So the algorithm, the AI agent, the AI agent will not make its position to get changed. Why? Because the newly generating states are giving the same value which this current state is having. So what happens here? The time taking process will be continued. So this point of process, we can say that it is a plateau kind of reasoning. One is the local maximum. This is the local maximum which can make the algorithm to get failed, right? Another one is plateau, this one, and the third one is this one ridge. Okay. So local maximum, it is a state that is better than its neighbors, but it is not better than some other states further away. Global maximum means it is the best possible state in the state space diagram. This is because at this state, objective function has the highest value. And next one is plateau or flat local maximum, we can say. It is a flat region of state space where neighboring states have the same value. We have already discussed these points. A ridge. It is a region which is higher than its neighbors, but itself has a slope. It is a special kind of local maximum, we can say. Current state means the region of state space diagram where we are currently present during the search process. Okay, so shoulder is also there, but at present we are not discussing this shoulder point. Okay. So what should be the solutions? Means if your algorithm is facing with this local maximum, then what should be the solution is only one important point, that is you have to apply the backtracking mechanism. Means visit the previous state to your current state and continue your search process. And if it is plateau, means if the algorithm is suffering with plateau, what you have to do is you need to make a big jump. Okay, you need to make a big jump, right? Just now we did right by identifying the weights 4, 7, 5. In that case, we identified that max. Initially, we have taken max equal to -1. Okay, so after keeping those values in some kind of array, we are doing the comparison, right? Comparison of 4 with 7. So we say that we know that 4 is lesser value and 7 is higher value. So what we are doing, instead of moving to the point where 4 is the weight, we are directly jumping to the point where 7 is the weight. Means we are considering the maximum value in that case. Means what we are doing a very big jump. Okay, so when it is the case, when it is the plateau case is there, so what you have to do is you need to make a very big jump. For that one, randomly you select a state. You randomly select a state which is far away from the current state. Okay, for example, this is there. So your current position is here. There are some other points in between. Generally what happens, we will try to move from this point to this point to this, and this point to this. But here in this case we are not doing. Whenever our algorithm is facing with this plateau kind of thing, directly you jump from this point to this point. Okay, so how we are doing, we are randomly selecting the state which is far away from the current state. But make sure that it is a non-plateau. Why? Because if this plateau is continuing like this, you made a jump, random jump, and you came to here, what happens again? There is some other plateau places there. Means you have to make a jump. Okay, we have to make a jump where there is no flat surface. Means instead of jumping from this point to this point, you better do jump directly to this point. Means you have to jump to a state which is far better than to your current state. Okay. The third one is rich. So if your algorithm is facing with rich kind of problem, so what you have to do is you need to make use of either 2 or more rules for testing. So what it implies is it is going to imply several directions at once. Okay. So this is all about the hill climbing process, and we can say that heuristic search technique is a better technique, or we can say it is a best technique when we are dealing with hill climbing kind of problems. So these are the 3 references which I have used for this session. We will try to come back with another important concept in the artificial intelligence. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.